So this is my first video on solving loci problems with complex numbers. So in this example, we're told that a complex number z is represented by the point q, and we're given that the magnitude of z minus 7 minus 5i is equal to 5. We've been asked to find the maximum value of the argument of z in the interval between negative pi and pi. Okay, so we should know we're going to use the property z minus z1 is equal to r, and this creates the locus of a circle. So now we need to find z1. So z minus z1, and we need to create this part here. So we'll put this in brackets and we'll have 7 plus 5i, and this will equal 5. Because when we multiply on this negative, we'll get negative 7 and negative 5i, okay? So we know that this will create a circle with a centre at 7, 5, and a radius of 5. So now we can sketch this on an Argand diagram. So we know that z will be at some point along the circumference of this circle, and what we're looking for is the maximum value of the argument from z. And we know that the argument is anti-clockwise from a real axis. So in this case, the maximum argument would be somewhere around here. And we know that z originates from the origin. Tangential to the circumference, then this will be the point of z. And we need to find this argument. But we also know that if this is a tangent, then the angle between the tangent and the radius will be 90 degrees. And the x-axis also acts as a tangent to the circle. So we'll have another radius and another 90 degrees. And now because these two radii are equal and these two angles are equal, we can bisect this argument to draw a line to the centre of a circle. And then this angle, we'll call alpha, will be equal to the other angle. So all we've done is we've bisected this argument to create two lots of alpha. And if we focus on this right angle triangle, we can find out what this alpha is. So we know it's got a base of 7 and a height of 5, and we're trying to find alpha. Well, we can just work out the tan of alpha is 7 over 5. We can work out alpha by working out the arctan of 7/5, and this gives us approximately 0.62 radians. So if this is 0.62, then the argument will be double that. So then the maximum argument of z will be double 0.62, 1.24 radians. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe. And you can download a full lesson and worksheet from my website, mrmathematics.com. Thanks again and take care. So then the maximum argument of z will be double 0.62, 1.24 radians. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe. And you can download a full lesson and worksheet from my website, mrmathematics.com. Thanks again and take care.